What is up? What is up, everyone? Welcome back. It's been a few days since I uh, recorded anything for the behavior tree tutorial videos. For those of you who do not remember, or maybe I cut it out, where we had reached the tutorial was the point where we had implemented the behavior tree that we initially designed and we tested it, and it didn't work. I couldn't get it to work. Let me quickly check if I'm on the right branch. I'm not. Okay, I'll quickly swap in a moment. But the behavior tree didn't work. What we observed was we would launch RViz, we would run everything.launch.py, we would use the nav2 panel in RViz to send action goals to nav through poses, and then we would put down AR tags, and then the rover would simply ignore the AR tags and try and go for the original goals that we had placed down. So that isn't what we wanted. What we wanted to see... Shit, that's not what I wanted. Ah! Alright, hold up. So let's go ahead and check out to feature behavior tree and go ahead and pop our stash, which will pop the one at the top, which is all the nav2 behavior stuff that I was working on. Great. So now, yeah, grid 2 will still be running, and now I can go ahead and open the behavior tree. Before I do that, let me go ahead and load up the behavior tree model, so we have all of our custom nodes. And I'll go ahead and open that. Beautiful. Go ahead and toggle all of that. So, oh, right, because I got rid of all the subtrees. Right. So, this is very difficult to look at now. I was having issues with Blackboard variables. If I go ahead and open up the behavior tree documentations, let me quickly find it. Okay, so here is the part that I was talking about. So for those of you who aren't aware, blackboards are essentially the term given to a hash table that serves as a storage for variables that need to be accessed by all the behavior tree nodes within a given behavior tree. The issue with blackboards, specifically when you have subtrees, is that each subtree has its own blackboard. So before, when I had, I think, like 3 or 4 different subtrees in my main behavior tree, there were certain variables that needed to be passed to all the nodes that could not be passed because they were in their own subtrees and they had their own blackboard variables and they weren't sharing the variables that needed to be shared. Now, the way you can get around this is by specifying this sort of remapping for the subtree, like using ports. But I'm going to be real with you, it's a lot of work, and I'd much prefer to just have everything in the one subtree and not have to specify 5 or 7 different ports for every single subtree. So this is what I'm going to do instead. I will leave it like this for now. For those of you who watched I believe it was the second video, you will already understand this behavior tree. This section here and all the nodes beneath it is the navigate through poses subtree, and then we have our custom conditions, and then again this is the navigate through poses subtree where we have modified the remove past goals action node with a remove past AR tags. So I've had an idea, right, about why this behavior tree, why it didn't work in RViz. Now, normally what I would do, if I hit a brick wall and I had no idea what the issue was, I would go ahead and I would open up like RCLPP, like I would create functions to like print to the terminal with debugging information, like variables, and like tell me what's going on. But I'm not going to do that for now because I think I already know potentially what the issue is. So my first theory, game theory, sorry, the first theory I have is the handling between navigating to pose and navigating to AR tags. So this navigation subtree and this navigation subtree. So the way that the rover decides which object to be navigating towards is pause. This seems an unnecessary amount of duplication, does it not? Is there a way to create a navigation subtree that combines the functionality of both? Pause. Before we jump into theories, this is an idea and I think it's worth exploring. So what is the difference between these two subtrees? And you know what? To help illustrate that, I'm going to go ahead and create a subtree. Just going to call it 1 because it's way too complicated to look at it right now. Great, here we go. So let's open up, let's open up 1 and 2. Here we go. Great. So this one, subtree number 1, this is navigate through poses, and this is navigate through AR tags. So theory number 1, or rather, I guess this is less of a theory, more of an improvement. The way that we've designed, at least intended to design this behavior tree, is that when it sees an AR tag, even if it sees multiple AR tags, it'll only go for one of them. So something that I've realized is this number 2 subtree, when we're navigating to AR tags, I shouldn't be copying the nav through poses. I should be copying the nav to pose because we're only considering one goal. So that is a change I'm going to implement in this video, hopefully, replacing this with a nav to pose subtree. That undermines the second point I was going to discuss, which is merging these two subtrees, because if I'm changing this to a nav to pose subtree, then there's probably no way for me to merge a nav to pose with a nav through pose. Unless, of course, the nav to pose from the nav to repose is actually quite similar to the nav through pose. A lot of nav through poses being thrown around here. Let me go ahead and pull up the nav to pose subtree from nav 2 and see how similar it is to nav through poses, and see if there is any merit in merging these two behavior trees. Hey, here we go. Alright, so let's go ahead and compare nav through pose with nav to pose. Alright, ready? This is nav to pose, nav through. Nav through, nav through. Okay, what is the difference? I can't see it. Alright, let's see, they both, so pipeline sequence, they both, so the controller with select a planner, they both have a rate controller for computing the path. A rate controller, that's just a decorator to specify how frequently the nodes below should be ticked. In this case, how frequently should a path be computed to the goal pose. So, yeah, this is correct. So in nav through pose, we are right that we have to remove the past goals before we compute the path to the poses. But the recovery sequence is identical, and then the final stage, follow path, and then a recovery sequence, follow path, recovery sequence. Very cool. And here we go, fallback. Go fallback. Oh, and this is, oh, right, sorry, this is just an entire recovery subtree. Okay, so the only difference between a nav through pose and a nav to pose is this. This and this. On this reactive sequence is only here to accommodate this additional action. Obviously, this action is different as well, but it is more or less, it's the same functionality, computed path to your goals. So, removing past goals. Okay. Redesigning the behavior tree to sort of merge together nav through pose and nav to pose and have the functionality to determine, hey, are we navigating to an AR tag, or are we navigating to a search area to occur in here. So, alright, we are going to, I want to create a new behavior tree. But yeah, well, this one. Actually, let's go ahead and back up what we've got right now. Git commit -all -m up. I'm gonna push. I don't even know what's in here. But I'm gonna push this as a backup because I want to change search for AR tags. So let's open up this and let's go ahead and just delete. I just delete. Okay, great. Here's our behavior tree. We are going to combine nav to pose and nav through pose. Now, the interesting thing, you know what? Why am I talking over this? Let's just copy this all over and then I can talk. Okay, cool. So what we're up to is essentially, here is the nav, yeah, this is the nav2 pose subtree, nav through pose, and the place where they change is down here. In nav2 pose, it's just a compute path to pose, but in nav through pose, it is a removed past goals, or remove the via points, really, and then compute a path through poses. So I've gone ahead and brought that over here. And so this is where it is. This is the difference. It's either connect to this for nav2 or connect that for nav3. So what we want is, so here we go. Let's get a little bit more room here. So, and drag this over as well. So basically, if we have an AR tag detected, we want to go here. And if we have no AR tag detected, we want to go here and just keep navigating through the via points. So navigate to pose. So let's go ahead and bring out that AR tag detected condition. I'm going to drag it out, right? So AR tag detected. If this returns true, we want to go here. If this returns false, we want to go here. Now this is a recovery node. So this can only have 2 children. So I think we're gonna have to have at least 2 control nodes. So if this returns true, we want to compute path to pose. Now, here's the thing about AR tag detected. Well, how does this whole tree work? So pipeline sequence, because and now we're finally going into the theories as to why I think the original behavior tree was flawed. The package responsible for detecting AR tag detection isn't always continuous. It's like sometimes, sometimes it sees the AR tag, sometimes it sees the AR tag, sometimes it doesn't. So I want to have a sort of tolerance for the frequency at which it sees an AR tag. As in, if it sees an AR tag, I want to at least be in an AR tag searching mode for, let's say, the next 5 seconds. As in, if we see the AR tag for a fraction of a second, and then we don't, we still keep looking for it for those 5 seconds. If within those, and every time it sees an AR tag, it reticks that timer. And if after, say, 5 seconds it doesn't see an AR tag, then it returns to what it was doing. That's what I want. I don't want it to tick the AR tag, it starts going for the AR tag, and the moment it stops seeing it, it returns back to where it was going. Because I think what can happen there is that it does a bit of like bouncing back and forth between the two and not having a nice cohesive movement towards either goal. So to do what I want, I think we're going to have to look into pipeline sequence, like these control nodes, and see how they work regarding reticking their children. So pipeline sequence is nav2 specific, that isn't in the behavior tree library. If we go back to here, so we've got sequence, with memory, we've got reactive sequence, and then we've got pipeline sequence. Let's see what I can find out about that. Condition, decorator, control, pipeline sequence, a variant of the sequence node that will retick previous children even if another child is running. So this sounds like something I don't want, actually. So a variant of a sequence node, it will retick previous children if another child is running. So this is the one that comes with the behavior tree library. We've got a sequence. If a child returns failure, it will restart and tick from the first child. If a child returns running, it'll only retake that running child. It won't retake the other ones. A reactive sequence will always take from the first child if any of them return failure running, and a sequence with memory will never retick from the start until it reaches the end. So, pardon me if I'm incorrect, but pipeline sequence just sounds like a reactive sequence. I don't see the difference because they both retick previous children if a child is running. So what's the difference? This is a reactive sequence, so it's going to do this, 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 this. And if any of these return running, it'll retake all of that again. That's what restart means. This is the same, no? Tick all previous again means every node up till this one will be reticked. Even if a previous node returns... Ah! Got it. Okay. This is the difference. Because if you're running a reactive sequence, right? Let's say we go success, 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 running, then a reactive sequence will go, all right, retake from the start again, success, success, running, and it'll go back. But this won't do that. Instead, it'll just go success, success, running, and then retake this one again. So what's the point? It's just retaking it for fun. But what's the use case of this? I still don't understand why this is better than... reactive sequence. The node is similar to the sequence node, with the issue will be that the children prior to the current are reticked. Ah, got it. So, okay, so this is so a pipeline sequence is supposed to work at as a sequence node, meaning that if any of the child returns fail, it'll restart. If any of them return running, it'll just take that same node again. But a pipeline sequence, okay, a sequence will go success, success, failure. Okay, next time this is take, it'll go success, success, running. Okay, next time this will take, it'll just go back here and assumes these are fine. A pipeline sequence, no matter what, is always going to retick. So success, success, failure, reticks, success, success, running. And what's going to happen is just like a normal sequence, a pipeline sequence is going to retake this node, but it's also going to retake this node and this node first. And the only reason it's going to do that is in case any of these return failure. If these return success or running, fine, whatever, doesn't matter. It's going to skip and it's going to keep going to the one it was at before. But if any of these return failure, then it's going to be like, okay, wait, hold up. This whole thing has failed, returned early. A normal sequence won't do that, but a pipeline sequence will. So it's basically just, do you want to retick the children constantly to check for failures? That's it. Got it. Okay. So this pipeline sequence is really just a sequence. It's just checking if any of this fails. No. I know what to do. I know what to do. I know exactly what to do. What it's supposed to do, what it does if it fails. If this returns running, return failure, which then means this returns failure, which means it then tries this. But the way that a recovery node works is that if it returns success only if the first child, so the second child will be executed if the first child returns failure, if the second child succeeds, and the first child will be executed again. So I actually don't want a recovery node here, I just want a fallback. And the question is, what kind of fallback? Do I want a normal fallback or a reactive fallback? I think I want a reactive fallback, right? Because I want to keep ticking this. I don't want to just tick, and then never tick that again. There's no pipeline fallback, right? There should be. Wouldn't be hard to implement. Recovery node, reactive fallback. If this returns failure, that's fine. Go to here, run. That'll return success, go back up. I just like, this should return failure unless it sees an AR tag for longer than, yeah, it sees an AR tag and then hold success for like 5 seconds. And then open up the ports because you, my friend, path through pose is path through pose. You're both going to use the same path, but yeah, goal, exactly. So AR tag detected. Also, AR tag detected is going to need a new port then, because you're going to need the gold as well. Yeah. Okay, we're collapsing everything into one node. This isn't what I wanted initially, but this is what works now. Alright, I'm just going to modify this. So you're going to have an input port. Can I, like, zoom in? Hello? Okay, you're going to have input visitor goals. You're going to output the ID, and you're going to output the scene IDs. It's going to be the ID. So did AR tags. It's going to be detected AR tag ID. Then this is going to be goal. It's going to be detected AR tag pose. Okay, great. And then open group 2, and we're going to go ahead and reload this. Why didn't that work? Oh, I had to select. Okay. Great. Okay. So scene IDs is going to be scene IDs. Output is going to be ID. Goal is just going to go into there. And then oh, ha ha ha. But if we're running through a nav2 pose subtree, then this is just going to go to the first, it's going to go, right, okay, right now, in its current state, this is going to find an AR tag, go to it, and then attempt to try and get close enough within the tolerances determined by the controller server that it is quote unquote arrived at its goal and then exit the behavior tree. It's not going to try to get to the behavior tree, get to the AR tag. Once it gets close enough, it removes it as a goal and then returns and never goes back to the AR tag. This isn't going to search for AR tags. This is essentially a this is essentially search for AR tag behavior tree, which isn't bad in of itself, but it does fall short of what I initially wanted. I wanted a search for AR tags plural. How can I do that? Search for AR tags. Well, the best way would be to not change into a nav2 pose. The best way would be to do nav through pose and prepend the goals array. Prepend meaning that instead of appending at the back, you insert at the front. That's what prepend means. So you prepend the AR tag goal. So I think we don't, let's not do, oh, it's really stretch. Oh, okay, let's not do the, right now what we're doing is nav through pose, then if we see an AR tag, let's do nav to pose to the AR tag. Let's not do that. Let's instead do nav through pose, and if an AR tag is detected, we're going to push the goal from here of that first AR tag we've seen. We're going to push it to the front of this goals array, and then that is going to, because this is a reactive sequence, it's constantly being reticked, it's going to cause it to recompute the path to be like, oh, new via point, this AR tag that I have to go to there right now, and then I can go back to where I was. So let's have another node that does, ooh, and here's where it gets dangerous. Because I can have a node, I was thinking I was going to add an action node here that takes in that goal and then pushes it onto goals. And what I realized is if I have it do that like constantly, like at a very high frequency, the size of this goals array is going to balloon. It's going to skyrocket because I'm constantly pushing new goals on the front of it. So I have to somehow limit it. But I can't do AR tag detected and then push the first goal I see and then only keep that one. Do you know what I mean? Because like as we get closer to the AR tag, we're going to get better and more accurate poses. So I have to keep pushing the most up-to-date pose onto the goals. But the issue with that is I can't, if I keep pushing, it's going to balloon the size of the vector. But I can't grab the first goal. Like, so either I keep pushing them on, or I grab the, or I can like, ideally I push on the first goal and then I just pop, edit, re-push. But there's no way to tell if I've already pushed on an AR tag goal or not. I guess I could have like a blackboard boolean variable, like if I push it on or not, then set that to true. Is that what I want to do? That doesn't really feel right to me though. It doesn't feel clean. If something is right, then it feels right. You know, it feels clean. Ooh. That's an idea. I do like that idea. I do like this idea that I've just had. So, in this action node, where I'm updating the AR tag goal pose, what if I have something very similar to remove past goals, where I grab the first goal and then I check, hey, is the goal I'm currently going to within a close enough tolerance to where I think the AR tag is? If it is, then update it, you know, with what is presumably the most recent accurate version of the AR tag pose. If they're not close to each other at all, then it's probably some random goal pose that was given to me by the operator when the behavior tree started and I shouldn't override it. And I can have it be like, and I can have it be like, have a radius value. I can just copy all the same functionality. It's good, it's good, it's good, it's good. I like it, dude. I like it. It's clean. Okay, we're gonna call this updates AR tag goal. Oh yeah. Okay. Oh yeah. All right. Gonna do this. Okay, and we're gonna get some ports on this baby. Let's go ahead and do input goal, output goals, and we can go ahead and add in radius to get that footprint as well. Yes. Oh, and I guess I would need everything else as well, right? Because I'm comparing the freaking the poses. I'm transforming the poses, dude. So I need radius. Input goal. Radius. Global frame. And I'll get robot base frame output. Huge. Oh, I'm gonna need. I'm gonna need input goals as well. I need the input goal and the input goals. Yeah, that's not gonna be confusing at all. That radius. I don't know. Let's call it like 2 meters. Global frame blank blank. So how's this gonna work? Boom. Success. Success. Running, 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 running. Let's just say this returns failure. Failure. So we go up here. We go here. Success. 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 We followed paths. Okay, we're following the path. We're following the path, and this is returning running. We're following the path. We're going through the search area. Running, running, running. And this is a pipeline sequence. So it's constantly retaking the children before it. It's constantly retaking, 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 retaking. Goes here. Boom, boom, boom. Goes down here, goes down here, goes down here. Hey, AI tag detected. Success. Okay, boom. Success. All right. Then we go to the next one. All right. Success. Yeah. Yes, this is always going to return success because it's either updating the front goals pose or it's pushing on a new one if it's not within the tolerance. So it's always returning success. This one, boom, found an AR tag. And I have that timer thing so it like latches it. Boom, success. Go up here. This returns success. So we're not doing this. We're doing this. Shit. Shit. I say shit because I'm not updating the path. I need it to still go here. Wait, then isn't this just like isn't it just this then? Because I still need it to do all that. So let's go from the beginning again. Success, success, success. Ah, shit. Failure, bro. Oh. If this returns failure, then it doesn't do anything. If it returns success, it won't skip it. I mean, if it returns running, it won't skip it. So I need this fallback. But if this returns success, if this returns failure, then I want you to go here. But if this returns success, then I want you to go here as well. What? What? What am I talking about, dude? Does that even make sense? Okay. If we don't detect an AR tag, keep on going as normal. If we do detect an AR tag, then we keep on going as normal because the goals has been updated to include the AR tag. So I basically always need, and I always want to tick this. Always want to tick this under a reactive sequence. That's what I always want to be happening. I always want this under reactive. I always want this to be ticked, but I just don't want its output to affect these two. I already know the answer. I already know the answer. I already know the answer. So if the child returns running, no, will this ever return running? This AR tag detected will only ever return success or failure. This will only ever return success or failure. This will only ever return success or failure. So it's never going to return running, meaning it's always going to return failure, force failure. Yeah, because the outcome of this doesn't affect anything, because it's affecting the Blackboard variables. Yes. But then do I even need a reactive fallback? I can just make this a reactive sequence and then have this be force success. Force success with a reactive sequence or force failure. Force failure with reactive fallback. Probably just get a reactive sequence then, right? And then decorator, force success. And force success if child is running, otherwise it always returns success. So this always returns success. So it will always retick it, but it's always going to tick this as well. Always going to retick this. If this returns success, and that returns success. Huge. I think this could work. Okay, you know what? Let's step through it. So, for the last... Hey, is this recording? This better be recording, dude. Alright. So, we run the behavior tree. Give it the goals to nav through poses, and we send it on its way. Controller, selected. Planner, selected. The rate, control. The recovery node, recovering. Hopefully not, actually. Hopefully it's going down here. And then it's going to go for success. So no matter what happens here, no matter what, this returns success. And we go here and we're navigating, we're moving past goals, we're navigating through poses. So it's always running that. So this is just running navigate through pose. But there's this additional caveat that, hey, if I've seen an AR tag, and I can add the timer, so if I've seen an AR tag within like the last 5 seconds, add that goal to goals. Add the pose of the AR tag to at the front of the goals. So it will navigate there as well. So nice, nice. Is there a way, is there another way of doing, if it's just nav through poses? Yeah, no, this is exactly how I would do it. Yeah, full success and, yep, cool. Cool. Dude. So all that thinking, literally, just to add 4 nodes. That's crazy. That's crazy. Okay. I think we're done here. I think we are ready I'm gonna have to implement new notes. I'm gonna have to delete the old ones and implement new ones. Far out. All right, I'm up for it. Ooh, actually, you know what? Maybe this is a blessing in disguise because all the other recordings have like a frozen frame. So who knows? All right, let's go ahead and get to it.